All right, so the week 3 Webcasted problem, new Roman 1. So first I want to showcase my old Roman so I can show how I go from this one to the new Roman. So for my original one, for old Roman, first we make sure that the number is larger than 0, otherwise we print out the statement and just exit. And then here essentially making use of the modulo operand to see how many of each one we need. For old Roman, this is relatively simple because it's just each one of the letters stands for each one of the values. So an M for 1000, D for 500, C for 100, L for 50, X for 10, V for 5, and I for 1. So all we have to do is make sure that we remove all of the numbers that are larger than that. And if you notice, every number that we are doing the mod by divides all the ones above it evenly. So 1000, 500, 100, 50, and 10 are all divisible by 5. So we are only going to have the ones that are all divisible, and 5 are all divisible by 1 to start with, because everything else. Then going up 1, everything else is divisible by 5, by 10, by 50, by 100, and then, 1000 there. So with that in mind, we're going to copy that over into our new one. And we need to add extra ones though. Then we're just returning however many M's we saw we needed, D's, C's, L's, X's, V's, and I's. Now, it gets a little bit more complicated for the new Roman because now we also need to account for CM, CD, XC, XL, IX, and IV. So in order to do that, first I'm just going to add them into this return statement as needed. So we would have our M's, and then we would do plus the CM times CM's plus the D plus the CD between these two. And then we have our C, and then it's XC. And then we have the L, followed by the XL. And then we have the X, followed by the IX. And then we have the V followed by the IV. So now we need these. So what I'm going to do is that I'm going to divide it into chunks just to make it a bit easier to see. So first we have our M's, and now we need to deal with everything that's below the 1000, so all of the hundreds places, right? So that's CM's is the first one, and that's going to be num mod 1000, and then modulo CM's is just, this, and then it's divided by 900. Now this is going to give us all of the 900. So we take out the thousands place, so if the number is 1900, then we see that so if it was 1900, right, that mod 1000 will give us just 900, which divided by 900 would give us 1. However, if the number was something where 900 would not qualify, right, so if this was 1800, the mod 1000 would give us 800, and then divided by 900, since this is integer division, we would have 0. So this still works out. So it's the CMs, and then it's the Ds, which we have here. And now this one we're gonna have to change a little bit. It's not just mod 1000, because if we just did mod 1000, right, then we would have the case where if we did as above 1900, if we do mod 1000, that's gonna give us the 900, and that divided by 500 would give us 1, even though this should really be 0 because we don't need any D's because the CM took care of it. So we need to mod by 900 as well, so that in here it would go like this. This would be equal to 1, and then divided by 500 is 0. So added here, mod 900, and then divided by 500. Now we move on to the CDs. So I need to add one more here. CDs, so it's going to be num mod 900 now, and then mod 500. Now, we don't need to mod by the 1000 anymore because 1000 is divisible by 500, so that one will take care of both of those. And then we divide by 400. Okay, and then after the CDs, we have the CS. And on this one, we're gonna have to mod by 400 at the end of this. As with above, we're dividing by 400 here, so we need to mod by 400 here so we can make sure that we're not going to repeat or double count any of our values. And then after the CS, we're now moving into dividing by numbers smaller than 100. So we'll leave an extra space there, just to make it a little bit easier to see. And let's actually add a space there and there to help it align better. There, and might as well move this here, and this here, and not there. Just so it all aligns better. Easier to read. Okay, so now the next one after the C, which is value for 100, is going to be 90, which is the XC. So XCs is equal to the number modulo 100. Now in this one we just have to do the 100 because we are every other thing that we divided by before this is divisible by 100. So this will get rid of everything above that pretty nicely. Same way that at the start here we just did mod by 1000. Here we can just do mod by 100, and then of course divide by 90. And then here's where the pattern is gonna really start to emerge, right? We see that we had 1000 and then 1000 and then 900. So this is gonna be 100, 100, and mod 90. So really this is starting to see, you can start seeing that this is really just gonna be same as the block above, but with one less zero on each one. Let's bring this out here, and then this will be 50. Okay, and then after the LS, we divide by 50. Now we need to do the XLS, which is the 40s. So that one is going to be to the number modulo. This is 40, so we need to do the 90 and then mod 50. And add an extra space to make it align nicely, and then we divide by 40. And again, we see that this line, line 16, is a pretty clear reflection of line 11. And then we do, after the XLS, then it's just the X's, but we need to add the mod 40. And we're dividing by 10 in this one, and now we're going to be dividing by numbers smaller than 10, so this is going to be our third block, and it starts with the IXS's, which is, of course, the 9s. So this will be num mod 10, which, as above, everything else is going to be divisible by. So let's just then divide by 9. And then after the IXS, we do have the V's. So those are just by 5, but we need to count here for the 9 that we used above. So mod 9. And then it's time for the 4s. So IVS is equal to the number modulo 9, and then modulo 5, and then divide by 4. And then the last one is going to be by, we're going to be dividing by 1, so we just need to add the mod 4 there, and there. Okay, now it's aligned nicely. I'll add some extra ones here to make them all align. This is in no way really required. I'm just very much a fan of very easily parsed code where you can just clearly see the relationship between all the different variables. Now I'll just switch the code on the bottom that I wrote to just get the number that we're going to be switching. And we can now open up our terminal. Berkeley ICS. And we see that New Roman is there, so if we run New Roman, we have a syntax error on line 23. Forgot a plus sign. Try that one more time. There we go. Okay, so if we wanted to do 1, that's just going to be I, and if we do 4, that'll be 4. Actually, let me rewrite this. I'm going to add a little while loop here just so that I don't have to deal with starting the program over and over again while I showcase all the different numbers. So let's just do, we'll bring this stuff out. So now we have the number, and then while number does not equal 0, I'll just have that as my condition. We're going to put the number and then ask for a new one. Right, that should do it. This we go. Okay, so yeah, now we can just go over and over again. So enter the numbers. We saw 1, we saw 4, we can see 5, we can see 9. Let's do one that has more than 1, so 19. So that's going to be XIX. We're going up to the 1000, so let's do the 1000 is just M, 900 is CM, so 1900 is MCM. And you could run this as long as you please, and at the end of it, I just press 0, and we exit the loop. Alright, and this is the one for week 3.